So for a body to accelerate, we need an external unbalanced force. So always remember, Newton's first law is applicable to every body. Now the second point. As per Newton's first law, state of rest and state of uniform motion in a straight line are both natural states of a body. Earlier people used to feel if a body is at rest, it is in its natural state. A body moving in uniform motion in a straight line is not in its natural state. It wants to come to rest. So that misconception was corrected first by Galileo and then by Newton. Third point, inertia of rest. The tendency of a body to remain at rest unless acted upon by an external unbalanced force is called inertia of rest. Inertia of motion. The tendency of a body to keep moving in a straight line with uniform motion unless acted upon by an external unbalanced force is called inertia of motion. So Newton's first law basically defines inertia. Only an external unbalanced force can accelerate a body. Internal forces cannot accelerate a body. So this is very important to understand. Only an external unbalanced force can accelerate a body. Now a little bit later we will see that we can derive the equation F equal to ma from Newton's second law. This is valid when mass is constant. Now from this equation, if F is equal to 0, then acceleration will be equal to 0. And this is what is Newton's first law. So Newton's first law can be mathematically derived from Newton's second law. Same way, we can mathematically derive Newton's third law from Newton's second law. Then why are the first and third law required? If both can be derived mathematically from second law. The reason why first law is required, because Newton's first law defines an inertial frame of reference. And without defining an inertial frame of reference, Newton's second law cannot be stated. Why do we need the third law? Third law clearly states that action is equal to minus reaction. This may not be so obvious from the second law, that's why the third law is there. Now let us try to understand inertial frame of reference. What is an inertial frame of reference? Inertial frame of reference is a frame of reference in which Newton's laws can be directly applied. There is another way of looking at inertial frame of reference. An inertial frame of reference is a frame of reference that is either at rest or moving with uniform velocity with respect to another inertial frame of reference. So if this is an inertial frame of reference, any other frame of reference that is either at rest with respect to this or moving with a uniform velocity with respect to this will also be an inertial frame of reference. Now how to find the first inertial frame of reference? Some authors give a simpler definition. Inertial frame of reference is a frame of reference that is either at rest or moving with uniform velocity with respect to distant stars. Now the question is the Earth an inertial frame of reference? The Earth cannot be an inertial frame of reference because it is rotating and revolving round the sun. Then how can we apply Newton's laws on the Earth? We can apply Newton's laws on the Earth because the acceleration of the Earth is very small. So for problems involving small dimensions compared to the size of the Earth approximately behaves like an inertial frame of reference. So inertial frame of reference is a frame of reference in which Newton's laws can be directly applied. Now let us try to understand Newton's second law. Before that, let us try to understand what is force. Force is an interaction that can cause acceleration of a body. What is acceleration? A body is said to accelerate when the velocity changes either in magnitude or direction or both. Next important thing is momentum. Momentum is a measure of the quantity of motion contained in a body. It is given by the product of mass and velocity. Force is F vector, acceleration is A vector, and momentum is P vector. P vector is equal to M into V vector. So momentum is equal to mass into velocity. It is a measure of the quantity of motion contained in a body. Now let us state Newton's second law. The rate of change of momentum is directly proportional to the impressed force and takes place in the same direction as the force. So mathematically, rate of change of momentum is dp dt. This is proportional to the impressed force. So we take appropriate units, F becomes equal to dp dt. Now P vector is equal to M into V vector. So force becomes d dt of M V vector. Now if mass is constant, we can take mass outside the differentiation. So we get F vector equal to M dv vector dt. So from here we get the equation F equal to ma. This is one of the most important equations in mechanics.